Hi, in this session, we are continuing with VHDL test benches and we will create a VHDL test bench to write the data into an output text file. So for writing the data into a text file, we need to follow four steps. First, we open a text file in write mode. Then we write data into a line buffer. Then we print the line buffer data into a text file. And finally, once all the lines are printed, then we close the file. Now, step 1 and step 4 is actually one-time activity. Means we open the file at the starting in write mode and we close the file in the last once all the lines are printed. But step 2 and step 3 is repetitive until we write all the lines in the output text file. So in the step 2, we have this line buffer. This is actually a variable that is declared in the declaration section of your process block. And this acts as a buffer and it holds the text of one single line. And later, this line can be written into the output text file. Means we load data into a line buffer by using this statement. Write line buffer, comma, data to write, semicolon. We use write function for this, followed by line buffer and data to write inside the brackets. And once we have data of one line in this line buffer, we print this data into our output text file. So this is step 3. And for that, we use this statement. Write line, bracket, file handle, comma, line buffer, semicolon. So we use a write line function followed by the file handle and line buffer inside the brackets. And now we repeat this step 2 and step 3 until we write all the lines in our output text file. And finally, at the end of simulation, we simply close our output text file, which is step 4. Okay, so let's write a VHDL test bench to write some data into an output text file. So first, we will declare necessary libraries and packages. So as I explained in the last session, we need additional library, and that is std. And we need to declare TextIO package from this std library. So declare them first. Library IEEE use IEEE dot std underscore logic underscore 1164 dot all use IEEE dot numeric underscore std dot all library std use std dot textio dot all semicolon. So we have used library IEEE and its packages because we are needing them for different data types like std logic, etc., which we have used in our DUT device or device under test. So they will also be used in this test bench as well. So first we declared library IEEE and its packages, and then we declared std library and its packages so that we can read or write data from a text file. Next step is entity declaration. So this is very straight because we do not write any input output ports in test benches like we discussed in the last session. So our entity declaration will be entity test bench is and entity test bench semicolon. Now it's time for architecture part. So this is our architecture part for this test bench. First, we declare some signals or constant inside the architecture declaration section. So first is constant string. Second is signal x, which is std logic vector 3 down to 0, which has initialized value as 1010. And third is signal y, which is integer type and having an initial value of 100. So declare them constant c colon string colon equals to this is a string semicolon. signal x colon std logic vector 3 down to 0 colon equals to 1010 semicolon. Signal y colon integer colon equals to 100 semicolon. Now we start our architecture with begin keyword. And now we will write our process block in VHDL. So write file, write process, colon, process, file, output file, colon, text, semicolon, variable, line buffer, colon, line, semicolon, begin. Now, if you notice, then we have not written any signal in the sensitivity list of this process. So this is a special type of process block with no signals in the sensitivity list. And you must remember that this type of process blocks are not synthesizable, means we cannot implement them in FPGA. But we are fine with that because we do not implement test benches on FPGA. We are only using them in our PC just to simulate and test our designs. Now, important thing is because we are not writing sensitivity list here, so we will use wait statement inside this process to control the execution of this process block. Wait statements are used to precise the execution of VHDL code inside the process block, and they are great for test benches. Now we have declared a file handle named as output file, and that is in the text format. Next, we declared a line buffer. This is a variable and having data type as line. So this will hold data of current line. Next, we start our process block from begin keyword. So first step is opening a file in write mode, right? So we have this statement here. File open, output file, comma, output file dot txt, comma, write mode, semicolon. So file open is a VHDL function to open a file. Then output file is a file handler, which we have declared in the declaration part of this process declaration. Then we specified the output file name, which is output file.txt. And in the last, we specified the opening mode. So this file will open in write mode. Note that if this file output file.txt is not present in your drive, then VHDL simulator will automatically create it for you. And if it is already existing, then your file will be overwritten with the new data. Now we will write 3 lines one by one. So you can see there are 3 groups here. Each group is actually write one line into an output file. Means these 3 set of VHDL line will write first line in your output file. Another 3 set of VHDL line will write second line in your output file. Finally, these 3 VHDL lines will write third line in your output file. Okay, so let's understand these lines. So first we have written write line buffer, comma, string, signal x is, colon, bracket, bracket closed, semicolon. Write line buffer, comma, x, semicolon, write line, output file, comma, line buffer, semicolon. So what we are doing, first we are copying all the contents for our line 1. And then we will write this complete line into the output text file at once. So what is happening? First, we are writing data into a line buffer. And in this code, we are combining 2 data into one line. So first 2 VHDL statements here are copying data into a line buffer. So first we have this string, which will print signal x is, colon, and now in the second line, we append this line with value of x. So after executing these 2 lines, our line text will be signal x is, colon 1010, and then we will print this line into the output text file. So we have this third statement, write line output file, comma, line buffer, semicolon. So write line is a VHDL function, output file is our file handle, and line buffer is the current line. So it is your data from previous two statements here. So always remember that first we print all the data into a line buffer, and once all the data is copied in the line buffer, then only we print the line into the output text file. Okay. Okay, if you understand this, then we followed the same steps for line 2 and line 3 in these sections here. Like for line 2, we have these three VHDL statements. Write, line buffer, comma, string, signal y is, colon, double quotes closed, bracket closed, semicolon. Write, line buffer, comma, y, semicolon, write line, output file, comma, line buffer, semicolon. So first statement will print the string signal y is, and then second statement will print the value of y in the same line. So your line data will be signal y is colon 100. And finally, it will write this line into the output file from this third statement. Same for writing the third line, we have these three statements here. Write line buffer, comma, string C is, colon, bracket closed, semicolon. Write line buffer, comma, C, semicolon, write line, output file, comma, line buffer, semicolon. So our line data will be string C is, this is a string, because first we copied string C is, and then we printed value of constant C, which is again a string data type, and the value is, this is a string. So our line data will be string C is, colon, this is a string. And finally, we write this line data into output text file. So I hope this is clear to you. Now, once you write all the lines in the output text file, you have to close your text file as a final step. Remember, we discussed this in the last session. So we have this close statement here in VHDL. File underscore close, output file, semicolon. Here, file close is our VHDL function, and output file is our file handle, which we have declared, right? Now, this is an important step because we want this process to execute only once. Otherwise, every time this process execute, it will open the file, then overwrite the file, and then close the file. So this will happen in the infinite loop, and we do not want this, because once file is closed, it is closed. And if this process is re-triggered, then our file will be overwritten every time. Means we need to pause this process now. So we use this wait statement. So this statement is very simple. That is wait semicolon. And now your simulator will pause here or stop here. So this is very important step here. And now finally terminate this process block with end process semicolon, and last terminate this architecture block with end architecture semicolon. So this is the output file which will generate from this code. So you can see that it will print three lines in this output file.txt. Signal X is colon 1010, signal Y is colon 100, string C is colon, this is a string. In this code, we have only written three lines in this output text file. But I think now you can extend this list very easily. Well, generally we write important data into the text file. For example, values of our output. or matrix of input and output, etc., so that we can analyze them in the future. You can also print important messages like warning, notes, etc., and even error messages or failure messages, etc. Okay, so that's it for today. In the next session, we will read data from a text file in VHDL test benches. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.